Hi all, this is the fifth section of Industrial Hydraulics module number 2. In this section, going to discuss about importance of accumulator in a hydraulic circuit, types of accumulators, and what are the application of accumulators. So first of all, hydraulic accumulators. Hydraulic accumulators are mechanical devices which store high pressure hydraulic oil during the ideal period of actuator and releases the high pressure oil to the cylinder during extension and retraction. So hydraulic accumulators are mechanical devices which is used to store high pressure of hydraulic oil during the ideal period of actuators. So during the ideal period of the actuators, the hydraulic accumulator that will store the energy of hydraulic oil and releases that high pressure hydraulic oil to the cylinder whenever required. So hydraulic accumulators are basically energy storing devices, and it is also known as secondary source of energy in hydraulic circuits. So what is the importance of a hydraulic accumulator in a hydraulic circuit? I am going to explain that with this hydraulic circuit diagram. See here, this is the accumulator. So initially I am going to explain what will be happening without an accumulator in a hydraulic circuit. The main components in the hydraulic circuit are a hydraulic reservoir, a pump, pressure relief valve, 4x2 DCB, double acting cylinder, and this circuit is used for sheet metal operation. So here is a punch and die, and this is a sheet metal. So during the working, there will be extension stroke and retraction stroke. So during extension stroke means punch is moving in downward direction and exerting a pressure over the sheet metal. So during the extension stroke, the port P is connected to port A and port B is connected to port T. Then what will be happen? Highly pressurized hydraulic oil flow through port P to port A to the cylinder. So cylinder have two sides. This is the piston side and this is the rod side. So highly pressurized hydraulic oil that is flow to the piston side of the cylinder. Then the piston move downward direction. At the same time, the hydraulic oil in the rod side of the cylinder flow through port B to port T to the reservoir. Then retraction stroke, the direction control valve is shifted to next position. So during this retraction stroke, the port P is connected to port B and port A is connected to port T. Then what will be happen? Highly pressurized hydraulic oil from the pump flow through port P to port B and it will flow through the rod side of the hydraulic cylinder. The hydraulic oil exert a pressure over the piston move in upward direction. At the same time, the hydraulic oil in the piston side of the hydraulic cylinder flow through port A to port P to the reservoir. See, during the end of the retraction stroke, the pump will be same working will be there. So during the end of the retraction stroke, there is an ideal period will be coming. So extension and retraction that will be taking place in a fraction of seconds. Then the ideal period that will take some times, because during the ideal period the sheet metal will be changing, another sheet metal will be putting over the die. That is the ideal period. So during the ideal period the pump will be working and the high pressurized hydraulic oil that will be flow through pressure relief valve to the reservoir tank. So during the ideal period of the actuator, ideal period means the time at which the sheet metal is changing under the punch. So during the ideal period, the pump will be working, but the energy of the hydraulic oil will be not utilizing. It will be flow through pressure relief valve to the reservoir tank. So energy of the hydraulic oil is not using. So here is the purpose of the accumulator. So at the ideal period, accumulator store the energy. So here accumulator is fixed. So during the ideal period, accumulator store the high pressurized oil energy in some manner, and that can be utilized later by the hydraulic actuator. So accumulator that will also act as a secondary source of energy. So as the accumulator also supplying the energy, the less small amount of pump will be, small size pump will be required for working the hydraulic cylinder. Large size pump is not required because accumulator that also supplying energy to the actuator. So that's the importance of the accumulator in a hydraulic circuit. So what's the importance of accumulator is, accumulator act as a secondary source of energy. It will store the pressure energy of hydraulic oil, and that energy can be utilized later by the hydraulic cylinder. Okay. So what are the classification of accumulators? See, there are various types of accumulator. They are weight load accumulator, spring load accumulator, hydra-pneumatic accumulator, that means gas load accumulator. In gas load accumulator, there are two classifications, non-separator type accumulator and separator type accumulator. In separator type accumulator, there are three classifications: piston type accumulator, diaphragm type accumulator, bladder type accumulator. So these are the wide classification of accumulator. So we can discuss one by one. So first one is weight loaded or gravity accumulator. So what is the purpose of an accumulator in a hydraulic circuit? I already discussed that. It is used for storing pressure energy of hydraulic oil or energy of hydraulic oil during the ideal period of the hydraulic actuator. So simply says that it is a energy storing device, a mechanical device which is used to store energy in some method. So weight load or gravity type accumulator. See, this is the figure of weight loaded or gravity type accumulator. In weight loaded or gravity type accumulator or dead weight accumulator consists a vertically mounted cylinder inside a piston. A piston is connected to piston rod. At the end of the piston rod there is a dead weight. So during the hydraulic oil will be flow into the cylinder. Dead weight accumulator that mainly consists a vertically mounted cylinder inside a piston, and the piston rod, other end of the piston rod is connected to a dead weight. When the pressurized hydraulic oil enter into this cylinder, the piston move upward direction. When the piston move upward direction, the dead weight also move upward direction. Then the energy of the hydraulic oil is storing in this accumulator as potential energy of the dead weight. So when the dead weight is moving in upward direction, the potential energy of the dead weight will be increasing. So hydraulic energy of the oil that will be storing as a potential energy in the dead weight. So whenever the energy is required, the dead weight move downward direction due to gravitational force, and the piston that will exert a pressure of the hydraulic oil, and the hydraulic oil pressure energy will be increased. So this is a graphical symbol of the dead weight accumulator. Second one is spring type accumulator. In the case of spring type accumulator, so this is the figure of spring type accumulator. See, in spring type accumulator, the energy of the hydraulic oil is storing in the spring as compression of the spring. Spring will be get compressed. When the hydraulic oil fill inside the cylinder, the spring will get compressed and storing the energy. So this is the spring load accumulator. So highly pressurized hydraulic oil which flow into the cylinder. The pressurized hydraulic oil exert a pressure over the piston. Piston move upward direction and the spring will compress. So the energy will be storing by compressing the spring. Okay, and that can be later utilized whenever required by the hydraulic actuator. So this is a graphical symbol of the spring load type accumulator. And third classification is the gas loaded accumulators. See, in gas load type accumulator, the energy is storing in the inert gas. See, gases are compressible and liquid are non-compressible. So energy of the non-compressible liquid that will be storing in the compressible gases, inert gas are commonly used. Inert gas like argon, nitrogen are commonly using. Maximum nitrogen is used to fill the accumulators. And oxygen is not commonly using because oxygen react with the oil under pressure can produce explosion. Okay, so in gas load accumulator, the energy is storing by compressing the inert gas like argon, helium, etc. There are two type of gas loaded accumulator, basically non-separate type accumulator and separate type accumulator. In non-separate type accumulator, so this is the figure of non-separate type accumulator. In non-separate type accumulator, there is no separation between the gas and liquid. There is no separating media between the gas. Gas means inert gas like argon and helium and or nitrogen and liquid. Oxygen is not using because oxygen react with the pressurized oil produce explosion. So commonly nitrogen will be using. Argon, nitrogen, etc. will be using, but nitrogen will be commonly using in all accumulators, these type accumulators. So here the nitrogen gas is filled in the accumulator to generate pressure in the hydraulic oil, and nitrogen gas will be filling here, and when the hydraulic oil will be flowed to the accumulator, the hydraulic oil that compress the nitrogen gas and the pressure is stored in the nitrogen gas. Nitrogen gas that get compressed and the pressure of the hydraulic oil will be stored, and that can be utilized later by the hydraulic actuator. And separate type accumulator. In the case of separate type accumulator, there is a separating element between the gas and the hydraulic oil. There is a separating element always present between gas and hydraulic oil. And there are three type of separating elements. Separating type accumulator, that is first one piston type accumulator, second one diaphragm accumulator, third one bladder accumulator. So there are three type of separate type accumulator. First one piston type accumulator, second one diaphragm accumulator, third one bladder type accumulator. So first one piston type accumulator. So in piston type accumulator, piston will act as a separating element between the gas and the hydraulic oil. So nitrogen gas are commonly using. Initially nitrogen gas is filling in this chamber. So this is inert gas chamber and this is oil chamber. So into this chamber the hydraulic oil will be filling. When the pressurized hydraulic oil will be filling in this chamber, the piston move upward direction and the nitrogen gas will be get compressed and storing the energy. So whenever required, the nitrogen gas expand and the piston move downward direction, oil get compressed and high pressure hydraulic oil that flow to actuator, and the hydraulic actuator that can utilize the energy. So in piston type actuator, piston type accumulator, the piston that will act as a separating element between the gas and the hydraulic oil. Second one is diaphragm type accumulator. See, in diaphragm accumulator, diaphragm is the elastic separator between the hydraulic fluid and gas. See, diaphragm type accumulator uses a diaphragm, that is the elastic separator between the hydraulic fluid and gas. Gas commonly using is nitrogen. So this is the diaphragm, that is the elastic member that will be separating the nitrogen gas and oil. Next one is bladder accumulator. See, in bladder accumulator, bladder is a elastic separator between the hydraulic fluid and the compressible gas. Bladder filled with nitrogen gas. So this is the bladder type accumulator. So this is the bladder. Initially this bladder is filled with nitrogen gas, and bladder that will act as the elastic separator between the oil and the inert gas. So bladder that will get compressed by the hydraulic oil, and the energy is stored in the inert gas. That energy can be later utilized by the hydraulic oil to pressurize the hydraulic oil. That can be utilized by the hydraulic actuator. So these are the classification of accumulator. This is a very important topic, classification of accumulators. So accumulators are classified. Once more, accumulators are classified: weight load accumulator, spring load accumulator, hydra pneumatic accumulator, gas load accumulator, non-separate type accumulator, and separate type accumulator, piston type, separate type accumulator. Again, three classification, that is piston type accumulator, diaphragm type accumulator, bladder type accumulator. So these are the classification of accumulators. Hydraulic accumulator symbols. So this is a symbol of no barrier accumulator. Gas charged accumulator, this is a symbol of gas charged accumulator. Spring load accumulator, this is a symbol of spring load accumulator. Weight load accumulator, this is a symbol of weight load accumulator. And this is a symbol of bladder type accumulator. And this is a symbol of piston type accumulator. Thus these are the important types and symbol of hydraulic accumulators. So next one, important topic, application of accumulators. There are 5 basic application of accumulators. First one, accumulator as an auxiliary power source. Second one, accumulator as hydraulic shock absorber. Third one, accumulator as thermal expansion compensator. Fourth one, accumulator as leakage compensator. Fifth one, accumulator as emergency power source. So these are the main applications of accumulators. So accumulator act as an auxiliary power source, accumulator act as a hydraulic shock absorber, accumulator act as a thermal expansion compensator, accumulator act as a leakage compensator, accumulator act as an emergency power source. So accumulator act as a auxiliary power source. See, this is the main function of an accumulator. Accumulator that will act as a auxiliary power source or secondary power source. So this is a simple circuit which will explain how accumulator act as a secondary power source or an auxiliary power source. See here, during the ideal period of hydraulic actuator, the hydraulic oil will be supplied to accumulator. And the accumulator that will store the hydraulic oil during the ideal period of the actuator. Then whenever the actuator requires the energy, hydraulic oil, the accumulator will supply hydraulic oil into the hydraulic actuator. So in this way, hydraulic accumulator that will act as a secondary power source or auxiliary power source. Then second one is accumulator act as a shock absorber. See, accumulator act as a shock absorber means whenever suddenly closing the control valve, a shock wave will be producing. Whenever the control valves are suddenly closing, there is a shock wave will be producing, and that shock wave will travel throughout the hydraulic circuit and damage the other components of the hydraulic circuit. Then hydraulic actuator that will absorb the shock wave and storing the energy in another form, and that energy can be utilized later. So this is accumulator act as a shock absorber. So hydraulic accumulator absorb the shock wave and storing the energy in the accumulator. Then third one is accumulator act as a thermal expansion compensator. Accumulator act as a thermal expansion compensator. When the hydraulic oil is continuously flowing through the circuit, see, almost all the hydraulic system are closed loop system. When the hydraulic oil is continuously flowing through the circuit, the heat of the hydraulic oil will be increased, or temperature of the hydraulic oil will be increased, and the hydraulic oil that will expand. The coefficient of expansion of hydraulic oil will be very large when compared to coefficient of expansion of pipelines. Then what will be happen if when the hydraulic oil will be expanding, the pipe will not be expanding. There is a chance that the pipe will burst, the pipelines will burst. So in order to avoid that problem, during thermal expansion, the accumulator will absorb the energy and accumulator will absorb the hydraulic coil energy and storing that can be utilized later. So that's the meaning of accumulator act as a thermal expansion compensator. Then accumulator act as a leakage compensator. Whenever there is any leakage in the hydraulic circuit, accumulator that will supply hydraulic oil to the circuit to compensate the leakage. So accumulator that will store the hydraulic oil, and whenever there is a leakage, accumulator will supply the hydraulic oil to the circuit and leakage will be compensated. The last one, accumulator act as a emergency power source. That's very important. Accumulator act as a emergency power source. See, accumulator act as a emergency power source means if there is any power failure will be occurring and the primary power source will be failed, the accumulator that will supply energy to the actuator can bring to the previous portion or initial portion. See, from this figure you can see this is the working of a double acting cylinder. The main components in the circuits are reservoir, filter, pump, pressure relief valve, 3/2 DCV, hydraulic cylinder, double acting hydraulic cylinder, check valve, accumulator, then again pressure relief valve. So here, after completing the extension stroke, the hydraulic oil flow to the accumulator through check valve. Then storing the hydraulic oil here in the accumulator. If there is a sudden power failure occur and there is no power for retracting the hydraulic cylinder back to original position, the accumulator will supply the energy. Accumulator will supply the hydraulic oil to the cylinder and the hydraulic oil return back to previous position. So in this way, accumulator act as an emergency power source to return the hydraulic actuator to initial position whenever the primary power source failure will be occurring. So these are the main functions of an accumulator, hydraulic accumulator in a hydraulic circuit. This is a very important topic. Usually examination it will be asking. So we can one more. What are the main functions of the accumulator in a hydraulic circuit? Accumulator act as an auxiliary power source. Accumulator act as a hydraulic shock absorber. Accumulator act as a thermal expansion compensator. Accumulator act as a leakage compensator. Accumulator act as an emergency power source. So these are the main contents in module 2. So we can write up the module 2. In module 2, we have discussed about the pump initially, positive displacement pump and non-positive displacement pump. Then working principle of positive displacement pump. In positive displacement pump, we have discussed about gear pump, weighing pump, piston pump. So these are very important classification of pump: gear pump, weighing pump, and piston pump. All are positive displacement pumps. Then we have discussed about selection of pump performance, then pressure intensifier, single acting intensifier, double acting intensifier, then accumulator. So these are the important topics in the second module. Okay, thank you.